Hello. So, hello students. How are you? Hope you are doing well. So, my name is Shanti Priya Kamath. I'm your chemistry teacher or lecturer. Okay. So, yes, I've completed my MSc in biochemistry and I'll be handling IB syllabus. Okay, for your chemistry. And yes, we are going to enjoy the IB syllabus chemistry and you are going to have lots of fun and with the proper roadmap outlines, understanding the proper subjects of it, and we are going to gain good number of marks. So, are you ready? Yes. So here we go. So today I have selected the topic unit 4 and the topic name is chemical bonding and its structure. So far students, we have been learning about it, like we have studied about it. Okay, that is chemical bonding and its structure. Is that about the different types of bonds? Okay, it can be ionic, covalent. Okay, then we also have studied about what type of different bonds. Okay, van der Waals bond. Okay, London forces. We have studied dispersion. Okay, theory. So taking that accountability, today we are going to study the outline, learning objectives, understanding, and the description and the application part of it. So this is how we are going to understand about basic important thing is about what is that? Chemical bonding. So here we go. Here we start with our learning objectives. So what are the learning objectives? Point number one, which is to recognize the formulas of what is that? Ionic compounds. First, we need to recognize the ionic compounds. Okay. So, for that, we need to know what is meant by bond first. First, we need to understand what is meant by bonding or bond. Bond is nothing but when atoms or elements or compounds or anything which is molecules, anything which is like ready to share and accept, ready to donate and accept, then it will form a bond. So understanding how ions are being formed and recalling the formulas of it. Okay. And we will have to work out in the formulas of ionic compounds from the charges of the ions and the description of the structure of sodium chloride as an example of ionic lattice. Okay. And then explain the physical properties of ionic compounds in terms of structure and its bonding. So here we go. Understanding the positive ions and the negative ions. So, what are the positive ions? First of all, positive ions are nothing but cations. Okay, cation is nothing but positive, which is ready to give, donate the electrons. That is, sodium is positively charged. Negative ions, anions. Okay, negative ions are what? Anions. Anions are what? These are non-metals, gaining the electrons. Gaining the electrons from the metals. And they tend to get negative. So, if you're donating, we get the plus. Okay, if we are donating, what do we get? The plus charge. If we're not donating, we get the minus charge. Okay, and we are accepting it, that means we are minus. Okay, like that. For example, I have written there. Okay, here I have written the different example, that is sodium. Standard example in chemistry. The standard example is what is that? About the sodium. Sodium is what? Positive. And negative may standard example is what? Chloride. Isn't it? Yes. So the number of electrons lost or gained is determined by the electronic configuration. I have highlighted and I have mentioned here. Now electronic configuration is nothing but about what? The electronic configuration is nothing but the shells. Okay, in which the what electrons have been revolving. Okay, so 1s2, 2s2, 2p6, 3s2 is what electronic configuration for? Can you identify and tell me the name? Yes, very good. For sodium metal. Very good. Similarly, for chloride, you will have to write down. Okay, so the ionic bond is due to the electrostatic attraction. Now, we need to understand what is meant by electrostatic force or attraction and how is it acting. That is, basically, ionic bond is due to electrostatic attractions when we state or say. That means it is having some force, positive, negative. When they come together, they form a close bond. What do they get? What do they form? A close bond. Okay, that is called as ionic bonding, wherein one is ready to share, one is ready to accept. Right? If this is there, then itself it is going to act. All right. All right. So this is it. This is the understanding of it. And then the conditions on how the ionic compounds are usually solids with lattice bonds, lattice structures, and lattice energies. We're going to study all of this. Okay. So are you interested? Are you feeling a little bit interested about it? Yes. So I'll be asking in between about the questions. Now you'll have to draw a circle and then you'll have to write down nucleus. Okay, sorry. Inside that you'll have to write down sodium. Okay, Na. The symbol of sodium. Then the electrons revolving in it. So that will be able to get to know. Okay, so electrons positioned outside the nucleus are less tightly held, isn't it? Outside wala electron is like for example, okay, for example, a small coda analogy I would just take it. Like for example, there's a lunch break, okay, in your school, and you students are going outside and getting some snacks or chips or anything, okay, or basically you're having your own lunch, and then you're entering the classroom of chemistry. So that first 10 students will enter by looking at the teacher in the classroom who is already present, will rush inside. And the one student who is outside just 2 minutes away will start to run. But then it is he or she is standing at the door. Okay, so the teacher will observe. Oh, the 10 students are inside and the one student is outside. So this teacher will punish the student, will say, you are not allowed to enter my session. So then the student will be, the one student who will be standing outside will obviously will have to stand outside. Okay. Now what happened? Now the 10 electrons are with sodium and one is outside. Outside matlab the outside the shell, right? It is not close by to the nucleus. So now it is pushing it away. That it wants to be stable. Now we don't want that one electron. So that one electron will go and combine with chloride and form NaCl bond, will help in NaCl bond. Okay, formation. Now let us see this. How does this happen? This happens only in case of valence electrons. Okay. Now what is valence electrons? Electrons positioned outside the nucleus are less tightly held by the outer electrons. Then it is referred to as valence electron. And it can be transferred easily to form a bond. That is the meaning of it. Okay, that's the meaning of it. All right. Now, although this is true for first 20 elements. Now, first 20 elements, what are those? We have previously studied in my shortcut form, song form. Ho, he, li, biba, kano, fane. Okay, namaga, alsipaskala, arkaka. So, this is nothing but hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, and then Namaga Alcipaskala is what? Sodium, magnesium. Yes, I want you to write down 11 to 20 as well. Okay, Namaga Alcipaskala Arkaka in short form. So 1 to 20 it is applicable for, but it is not applicable for the d orbitals. D matlab Skati Vakramane Ficoni Cusin. Skati. What is Ka? Sc is what? What is that? Scandium. So it is transition metal. Transition metals or elements do not tend to get involved with the ionic structures. Why? Because they exhibit more than one property of the valence electrons. Like for example, iron. Iron has +2 and +3 state. Two states it has. That's why it is not involved with this type of bonding. Okay, hope this is clear. Yes, they have mentioned here ferrous and ferric state. So when an atom loses electron, it forms a positive ion. Is it true? Yes. So then it is referred to as cation. When an atom gains, it forms a negative ion called as an anion. Okay. So now one assessment I'll be giving you, that is, this is the assessment for you. What is difference between metals and non-metals? I want you to write down the difference between the metals and the non-metals. Now the number of electrons lost by the elements in the group 1 and 2. Now group 1 to 18 is what? The vertical lines. And the horizontal ones are not counted as groups. Okay, understand this. Those are periods in the periodic table. We have already studied. Okay, all right. So the number of electrons lost by the elements in group 1 and group 2 when they form ions is given by the group number. And the number of electrons gained by the electrons in group 15 to 17 when they form ions is given by 18 minus the group number. Now everyone wants to be stable, isn't it? The question is, how do these electrons want to be stable? And why these electrons want to be stable? Why does not the electron? Basically, the atom or the element wants to be stable. And that stability is reached only when it will reach its octet state. Okay, octet state, or basically we can say that they want to get stabilized as like the group 18 elements. Okay, group 18 element, it wants to be stabilized. Okay, so yes, for that struggle itself, these all things are happening. And this is the cross and dot structure of magnesium oxide. Now, magnesium atomic number is what? What's the atomic number? Atomic number of magnesium is 12. The first two electrons are very close by to the nucleus, so it cannot be transferred outside. The second shell has 8. 2 plus 2 plus 2 plus 2 is 8. Okay? 2 into 4 times it is there. So 8. And outside there are 2 electrons. Now these 2 electrons are going to be involved with the sharing wala stuff. Okay? It is going to be easily shared, basically. It is going to lose its electron. And then oxygen is going to what? Gain those 2 electrons and form a bond with magnesium, called as magnesium oxide. Hope this is clear to you, students. Okay. All right. So now a quick recap or review for today's session of mine is that we have studied about ionic bonding. We've studied about what is meant by a bond. Then we have studied about valence electrons. What is meant by cation, anion. Let's go previously whatever we have studied. Then assessment I have given you. Then I have explained you about what are metals. Okay. Then I have explained you how the bond occurs and with an proper example of magnesium oxide. So hope my today's session is clear. Please take down this diagram and then I'll give you 1 minute to quickly note it down. And then tomorrow we are going to discuss about the assessment questions as well as the further application of it. In IBs, we are going to study the outline, the understanding portion, and the description and the application part of it. Okay. See you soon in my tomorrow's session. Please, if you have any questions to address now in my session or post my session, you can ask me anytime. Okay. I will be helping you or guiding you with this. And thank you. Hope my today's session you've enjoyed, right? All right. Thank you.